Hello, Algebra 2. This is going to be 9-6 mathematical modeling. Both your homework and this video are going to be somewhat short, so yay. I know 9-4 and 9-5 might, especially 9-4, might have been a little intense. So this is going to be about writing the equations given a graph or given an actual situation. How do you come up with the equation and the graph and translate it into something we can see? So let's do a little review of what the different transformations represent in your sine and cosine graph. So as a reminder, see this first number that gets added or subtracted. That represents your new sinusoidal axis, kind of the line that goes through the middle of your graph. A represents your amplitude, which is that distance from the middle. It's always positive, a positive distance to the high or the low point on your graph. If you had a negative in front of that A, it would represent a reflection, not a negative amplitude. Amplitude's a distance, so it's always positive. Then this D back here, a positive D, it's X minus whatever that D value is. That is where you start. And so that is your horizontal phase shift. That affects your graph horizontally, wherever you would start on the x-axis. And then the last one is this B value here. This tells you how many cycles you can complete in 2 pi or 360 to figure out what that new period might be. We usually do either 2 pi over B, that tells you the period, or if you know the period and are trying to find B because it's describing a situation, then we do this one, 2 pi, because it's related reciprocally. So 2 pi divided by the period gives you the B value if you had to write the equation. If they gave you the B value, 2 pi over B would give you the period. All right, so let's look at this, because the reality is, if you haven't noticed by now, and I did talk about it in the other videos, sine and cosine are basically the same graph. It's just about where you start looking at it. So I'm going to do these several ways. And what we're going to start off, I find it helpful. We have a vertical shift, that's our C value. Then you have your amplitude. We're going to look at what is our period and what is the phase shift. That's that B value, the D value, sorry. So in this first number 2, notice that it looks like I'm going up to 2 and down to 2, so that means my sinusoidal is 0. It hasn't moved. My amplitude is a distance of 2. My period, so to figure this out, you choose a point, any point. Find another point that is at the same height, and what is that distance? So when we look at that graph, that is a distance of 2 pi over 3. That's how long, that's the distance it took to complete one cycle, and then I would start to repeat. My phase shift in this particular graph, if I was going to do it as what I've just highlighted up here, my phase shift would be 0. But I'm going to give you a warning, we're going to do this as both a cosine and a sine. Dun, dun, dun. All right, so let's first do the pink version. The pink version will be cosine, because notice I'm starting high and I'm ending high, and that is a characteristic of a cosine graph. So we take these numbers, so normally you would have y equals c plus a cosine b x minus d. All right, well, our C value is 0. A is going to be 2 cosine. My period is 2 pi over 3, but I have to find the B value. So that's where I come back up here. B is going to be 2 pi divided by 2 pi divided by 3. So that's 2 pi. If we invert and multiply 3 over 2 pi, notice my B value is going to be 3. That's how you find that. And since I'm starting at 0, this is then just x. And that would be my equation. that's how I would do that. Now, I don't want to make this more difficult, but I do want to emphasize that you can do a cosine graph also as a sine graph. Notice, you know what, I'm not going to do it in this one because they didn't tell me what this value is here. So in this case, we're going to leave it like that. There is my equation. All right, this next one, we will do two different ways. And we're going to do the same thing where I'm going to look for a vertical shift. What is my amplitude? What is my period? And my phase shift, we're going to do two different ways depending on which graph we're looking at. Now, sometimes the easiest is to start at 0 here. So notice I'm starting on what would be considered the sinusoidal, and I'm going to end here. So we have to figure out, this is 1/2, that means that's 1/2, so this would be at 1, this is 1.5, this would be at 2. All right, so we know what our scale is here. So my vertical shift, looking at the labels they have on the y-axis, it looks like my sinusoidal is going to be at -1. My amplitude, which is the distance from the sinusoidal to a high point, is an amplitude of 2. My period, so it took me from 0 to then start the cycle again, took me a distance of 2. And if it's a sine graph, I'm starting at 0. So that's going to represent this green. So we're going to do sine in green. So if I put this all together, remember now it's going to be y equals c plus a. We're going to do this as a sine graph, b x minus d. So filling things in, y equals -1 plus 2 sine. Now the period is 2. That's not my b value. The b value, again, so we're going to come up here, is b is going to equal 2 pi divided by the period. So that leaves me with pi. So this is going to be pi. And then we're starting on the x-axis, so d is going to be 0 as well. That would be my sine graph for that particular function. However, again, I don't want to confuse the issue, but I do want to emphasize you can do these correctly two different ways. Notice I can also start high and end high, because that's what a cosine graph would do. And everything stays the same. Everything stays the same except where did I start? I now started at a positive 1/2. So the only difference will be now y equals same sinusoidal, -1, same amplitude. Oh, whoops, hello, wake up. Sorry, that should be a cosine now. We're doing this as a cosine. Same pi for the b value, but now it's going to be x minus 1/2. So the only difference is where did I start? You can always do these graphs two different ways. The easiest is if you can start at 0, but I want you to see that you can also do it correctly by shifting it to where the cosine at a high point. All right, now let's look at if you have a situation. Ferris wheel is the most common one. So let's decipher what this information is. I'm a very visual person, so I like to actually make the graph first and then translate that graph into the equation like we just did. So we're going to go from words to graph to equation. And let's remind ourselves we want to figure out what these particular values are to fill in. All right, a Ferris wheel. Actually, I'm going to give you a little. A Ferris wheel, you know, Ferris wheels go round and, that was silly of me. Ferris wheels cannot, so let's say this bottom line here is the ground. You don't want to hit the ground on a Ferris wheel, because that's not a good thing. I know, that wasn't a very good circle, but you're going to live. Oh, actually, you know what? Sorry, I'm going to be really annoying here. I want to graph. Hey, you said I could graph a circle. I want to graph a circle. I don't know. It's not giving me a... No. Sorry, I'm playing. Okay, I'll just graph my pathetic circle. There we go. Okay, let's read this. A Ferris wheel has a diameter of 30 feet. All right, so this is a total distance of 30 feet. And it is 6 feet off the ground. So down here, that is 6 feet off the ground. It takes 2 minutes for the Ferris wheel to make one revolution. One revolution, if you think about a unit circle, one revolution equals 2 pi. So we have that 2 minutes equals 2 pi, right? Because we have 2 minutes equals 1 revolution. So that means that, well, let's just keep that there for a minute and keep reading. It makes 1 revolution every 2 minutes. Write a model for the height of the wheel as a function of time if the wheel starts at its lowest point. So it's going to start at 6. That's going to be the low. So I'm going to come over here to my graph, and I know that 6 is going to be my low point. Now if I add 30 to that, that means my high point is going to happen at 36 because the diameter of the wheel is from 6 to 36. So my halfway point, because my amplitude here is the distance from the middle, so the amplitude we know is going to be 15, but that puts this middle point, you could either take an average of those, that's 42, half of 42 is 21. That's going to be your new sinusoidal. So my vertical shift is going to be 21. All right, I hope you're following me with this. So the lowest is at 6 feet because you don't want to hit the ground. It's not a good thing. High point is going to be at 36. That's 30 plus the 6 feet we're off the ground, which means half that distance is 21. Now they told us that it takes 2 minutes to do a full cycle. So remember, we always do to figure out we know the period. We know the period is 2 minutes to complete one cycle. What we want, if we're going to do the equation, is we want the b value. So remember up above, to find b, you do 2 pi divided by the period, which just gives me pi. And it's kind of like dividing both sides. So my b value, when I write the equation, is going to be pi. Now this one said we're starting at a low point, so my phase shift, so this means if I'm starting at a low point and I'm going to go to a low point, that's going to be a cosine graph that's been reflected. Instead of going high to high, it's going to go low to low. So that means my phase shift is going to be 0. What is my graph going to look like? So here I am. What I always do, I kind of cheat. I'm going to start low, and I'm going to just do my cosine graph. So there's my 5 points, and then I'm going to label my axis. So this was at 0. We started low. 2 minutes later, we finished our cycle, which means I reached a halfway point at 1 minute. And this would then be 30 seconds, or rather we should keep the same units. So this would be at half of a minute. You could do it as seconds or you can do it as minutes, I don't really care. This would then be 1.5 minutes. And should I do it as seconds? I don't really, doesn't really matter. I'm gonna keep it that way. Okay, so let's put it in. Remember that we put these numbers in, let me just remind you, y equals c plus a. We're doing this as a cosine graph, b x minus d. So filling in the information, y equals, my vertical shift is at 21. My amplitude is 15, but it's reflected, so it's going to be a minus 15. That minus represents the reflection. It's cosine. The b value we found was pi, and we're starting at 0, so I can just put an x on it. And that would be the equation based on that model. So again, what I do is I read through the words. I kind of, especially if it's a Ferris wheel, I always like to draw a little Ferris wheel and kind of mark things up so I can get an idea of what to mark on my y-axis, because that gives me, this is my low point, my high point is going to be 6 plus 30, so that helps me kind of mark off my y-axis. And then I can either put, so they told us 1 period is 2 minutes, and then you can find all your halfway points, or sometimes I just graph the cosine 1 cycle and then go back and label the axis. Either way works. I hope this is okay. That's it for 9-6.